Okay, this is the Unit 1 test review. It's going to be a little bit longer because it has extra examples, but number 1 talks about the domain, so some things you need to know about the domain. The domain is going to be your x values, and it has to go from left to right. So the way we looked at it in class was we basically cut the graph in half, and we look at the left side and the right side. So there's 3 things that could happen. If you see a white dot, you have to use parentheses. If you see a solid dot or a black dot, you got to use brackets. And then if you see an arrow, arrows mean you have to use an infinity. So if we're doing the domain of this graph, and if you just look at the far ends, on the left side you have a white dot. So you're going to use the x value for that white dot, which is 1, 2, 3, 4, 5, 6 to the left. And then you're going to go to the right side, and that has another white dot, so you go to the x value there, and that's going to be 2 to the right. So our domain is from -6 to 2 with parentheses. This one says state the domain. So the big thing about a square root is you can't have any negatives underneath the square root because it gives you an error in the calculator. So what you do is you take the stuff from inside, and you want to set it bigger than 0, so that way it's not negative, but it can also be equal to 0 because you can take the square root of 0. So you're gonna add 3 to both sides. So we'll add 3 to both sides first, and then we'll do 12x greater than or equal to 3. Then you'll divide by 12. So x is greater than or equal to 1/4. Now if you look at what that picture looks like, this is 1/4 right here. This would have to be a circle. Because it's equal to, we're going to have to color in that circle. It's going to be a solid circle. And then the greater than portion right here tells us that the graph is going to move to the right. So we use that to write our interval notation from left to right. So we're going to start off at 1/4. We'll have the bracket because it's a closed circle and it's equal to. And then it goes off into a positive infinity. Number 3. Looks like it's going to be a fraction, and we talked about this in the previous unit. Anytime you have a fraction, the top is irrelevant. So you're going to take the bottom and set that equal to 0, and you're going to solve it like normal. So we'll just subtract 4 from both sides. So you're going to end up with 7x is equal to -4, and then you just divide by 7. So the thing about this is x is actually not allowed to equal -4/7. So we would say that the domain is going to be all real numbers except that one number that we just found. So the way you would write this as an interval notation is, if you just look at the picture, if you have -4/7 right here and you don't want it to be -4/7, you would put an open circle or a white circle. It would be everything to the left and then everything to the right. So that means our interval notation would be -infinity to -4/7, and then union, and then -4/7 to infinity. That would be our domain. Okay, next one is asking for the roots. So we're getting into our key features. We're going to do 3 different examples of this of these key features. So what are roots? Roots are going to be on the x-axis, so they're your x-intercepts. So if you just look at the x-intercepts, so any spot where the graph touches x, that's going to be your solutions. So we're going to have one at -3, 0. We're going to have one at -1, 0. We're going to have another one at 1, 0. And then we're going to have a last one at 3, 0. So all 4 of those are answers because the graph touches 4 times. Now your increasing and decreasing intervals, the way we did this in class was, first of all, it has to be x values only, and you have to go from left to right when you read this graph. So if I do my x values from left to right, I need to figure out the parts of the graph where it's going up or down. So if we go from left to right, this part of the graph right here is headed down. Then this part of the graph after that dot is headed up. Then it's headed down after that dot, and then it goes back up. So our graph is broken up into a few sections, and the points of interest that we care about is basically going to be maximums and minimums. So this point right here is something that we really care about, so I'm going to stick a -2 right there. Here's another point where it changes direction, so I'm going to stick a 0 right here. Here's another point where it changes direction, so I'll stick a 2 right there. And then our graph always has a negative infinity to infinity. So what we do here is we just go section by section, starting with this section here. This graph is headed down in that section, so that's going to be a decreasing section, so it's negative infinity to negative 2. And then the next section would go from here to here, so from negative 2 to infinity would be increasing. Or not infinity, sorry. That's negative 2 to 0. And then the next section would go from here to here, so from 0 to 2, and that graph is going down. So we're going to put a union because it's got a second part of an answer. And that's going to go from 0 to 2. And then the last portion is from here to here, so that part of the graph is headed down. So that's going to go from 2 to infinity. So I'll put a union and then go from 2 to infinity. So this graph has 2 sections where it's going up and 2 sections where it's going down. And then we just put a union in between each piece of those answers. The end behavior. So end behavior is all about which way the graph is facing at the ends. So that's a key right there. We only care about the ends. So the notation is set up to where if they tell you a negative infinity, that's the left side. And if they give you a positive infinity, which is this one here, that's going to be the right side. So if we look at the far, far ends, so if I look at the far, far left side, that has an arrow pointing up. And then this side over here also has an arrow pointing up. So if you ever have an arrow pointing up, up is going to be a positive infinity and down should be a negative infinity. So the left side points up and the right side points up, so they should both have the same answer of positive infinity. So this says as x approaches the left side, the y value goes up towards positive infinity, and as the x approaches the right side, the y value heads towards positive infinity. Okay, the next one is going to be your domain and range. So the domain, we already talked about earlier, is going to be x values. And that's going to go from left to right. So if I take this graph and just kind of cut it in half, we just need to look at the left end and the right end. The left end has an arrow, so that means that the graph is going to go left forever. The right end also has an arrow, so that means the graph is going to go to the right forever. So our domain is going to be from negative infinity to positive infinity. The range is going to be y values, but these ones have to go from bottom to top. And it has to go from bottom to top because we want to put them in order. So I'm going to go ahead and erase this part right here. And then we're going to cut the graph the other way. So we'll cut it this way. And so if I look at the bottom has a black dot here and a black dot here, and those happen to be at the same exact level. So anytime you see a black dot, you have to use the y value and a bracket. So it's going to be negative 15. And then the top, a lot of kids mistake this for the top, but this graph specifically has arrows right here. So arrows means that it continues on past that black dot. And even if there was only one arrow, the arrow always wins. So we're going to use the arrow to determine what the range is going to be. So it goes up forever. So that's going to be a positive infinity. Okay, the next one is the maximum and the minimum. The maximum is the highest point, and the lowest is the minimum. So the maximum should look something sort of like this. So it looks like this right here would be our maximum. So our maximum point is at 0, 9. And then the minimum is the exact opposite. So the minimum is going to be the bottom point. So that would be here and here. So this one has 2 minima. So the points would be located at -2, -15. We have a second one at +2, -15. So the maximum was 0, 9, and then we had a minimum at -2, -15. And we had a second one at +2, -15. So when they talk about the average rate of change, what they want from us is they want us to calculate y2 minus y1 over x2 minus x1. So they want it between the maximum and the minimum. There are 2 different minima, so you pretty much get to pick. So if I had to pick, I would pick obviously 0, 9 because it's the only one. And then I would also pick this one over here because this one has less negatives. So if I labeled this, this is going to be x1, y1, and this would be x2, y2. And so if I did the math and substituted, I'm going to have 4 spots to put in some numbers here. So I'll put in y2 first, so that's negative 15. Then I'll put 9 right in this spot right here because that's my y1. And then x2 is positive 2, and then x1 is 0. So if I do the math to this, negative 15 minus 9 is negative 24. And you can do this all in the calculator. And then this is all over 2. So if I divide that, my slope is going to be negative 12. Now, if I was to use the other 2 points, if I was to use 0, 9 along with negative 2, negative 15, the only thing that's going to happen is going to be the sign's going to flip. So this is going to be positive 12 if you were to use those points. Either way, when you do the test, if there are 2 minimum or 2 maxima, I'm going to go ahead and put both answers into the answer key, so it'll accept either one. Okay, and then we start all over, so we're going to do this again. We got some roots. Roots are the x-intercepts, so we have one here at negative 2, 0. Then we have a second one over here at 3, 0. And that's the only 2 spots where the graph touches the x-axis. Increasing, so I'm going to break this up into sections again. So this part right here, left to right, goes down. And this next part right here goes up. And the part after goes down. So the points that we really care about is the spots where it changes directions. So we're going to mark that on the x-axis, so that's negative 2. This one's actually at 1.5. So 1.5 goes there. Then we have an infinity on the right and a negative infinity on the left. So then we just basically go from section to section. So this section here, negative infinity to negative 2, the graph is going down. So negative infinity to negative 2 goes on the decreasing part. And we never use brackets on increase or decrease. And then the next section is this section here from negative 2 to 1.5. So that's increasing. And then the last section is from negative 1.5 to infinity. So that section is decreasing. So I'm going to put a union here and then 1.5 to infinity. So we have 2 sections where the graph is headed down and 1 section where the graph is headed up. End behavior is about the ends only. So I'm just looking at the ends. This first line right here is talking about the left side, and that's headed up. So that's an infinity. The right side is headed down. So that's going to be a negative infinity. Domain is left to right, x values only. So I'm looking at the graph and I'm cutting it in half, and then I look at the left side, I see an arrow. Left arrow is negative infinity, and then an arrow on the right side is going to be a positive infinity. So this graph heads left and right forever. And if I go ahead and cut the graph the other way, so if I cut it this way instead, the bottom has an arrow, so that's a negative infinity for the range, and the top has an arrow. So that's a positive infinity for the range. So the graph heads down and up forever. So some people confuse this because they want to use this point right here, but the arrow always wins because it goes past it, because we're trying to find the lowest and the highest that this graph's going to go. Maximum, remember the maximum is the top of the graph, so that'd be this point here. So I'd be at 1.5, 4.5. And then the minimum is going to be this point here. That's going to be at negative 2, 0. And remember, when you do a maximum and a minimum, you're not going to use infinities because infinity can't be used as a point. So the next question is to find the average rate of change between the maximum and the minimum. So let me write those down one more time. And then we have negative 2, 0. So this would be our x1, y1, and then x2, y2, because it's the first x, first y, second x, second y. The formula again is y2 minus y1 over x2 minus x1. So if I plug in the 4 numbers, like so, we're going to end up with 0 minus 4.5. And then x2 minus x1 would be negative 2 minus 1.5. And then this can all go in the calculator. So 0, well, actually I'll make the fraction first. So I'll have 0 minus parentheses 4.5 over negative 2. Actually, I'll put that in parentheses also. Negative 2 minus parentheses 1.5. Now, we don't really want decimal answers, so there's a button right above the 8, the FD, that changes from fraction to decimal and decimal to fraction, so the answer to this one would be 9/7. And since there aren't any multiple maxima or minima, that's just going to be the only answer in this question. So now we're starting the process all over again. Roots are on the x-axis, so we have solutions here at -2, 0, and 2, 0. Increasing and decreasing, so let me mark up my graph. From left to right, this part goes up, this part here heads down, and this part right here heads up, and this part right here heads down. So the points of interest that we care about is wherever it changes direction. So we're going to mark off -2. This point right here is where it changes direction, so I'm going to mark off 0, and it changes directions at 2, and then we always have a negative infinity on the left and a positive infinity on the right. So then we just go from section to section and put it wherever it goes. So the first section is going to be this section here. So that's going to be from -infinity to 2 where the graph heads up. So -infinity to 2. And then the next section is going to go from -2 to 0. That's heading down, -2 to 0. The next section is from 0 to 2. That's going up. So I'm going to put a union, 0 to 2. And then the last section is this section here. So from 2 to infinity is where the graph is headed down. A lot of people think that last infinity should be a negative because it's heading down, but we don't use y values. That's why I mark all of the values on the x-axis, because these are x-axis numbers only. End behavior is where the graph is facing at the ends. This graph doesn't have arrows, but see how this kind of goes to the edge of the graph? That typically means that it goes forever. So there's an arrow here and an arrow here. So we should have two answers that are the same because they're headed in the same direction. And since it's down, down, that's going to be -infinity to -infinity for these two answers. Okay, domain. Domain is left to right x values. This has a graph on the arrow on the left and an arrow on the right. So that's going to be -infinity to infinity because it goes left forever and right forever. Then we cut the graph the other way. So if I cut it in half here, the bottom has an arrow. So that's going to be -infinity. That means it heads down forever. And then there's a top part here, and it looks like it's going to be a tie right here at 0. So it goes all the way to 0, and those were black dots, so we're going to put brackets on them. Maximum is the top part. So we got two tops right here. So that's going to be at -2, 0, and +2, 0. And then the minimum is down here at the bottom. And if you look carefully, that doesn't look like it's at -15. Maybe it's at -16. So we're going to have to estimate that one. So that's at 0, -16 down here, that point right there. And then the next question is going to be to find the rate of change. So let me write those one more time. 2, 0, and then 0, -16. Like I said before, pick whichever two you want. Just make sure it's one maximum and one minimum. So we can pretty much pick any two we want. I'm going to pick this one because it has less negatives, and obviously I have to use the minimum. So I'm going to go with x1, y1, and then x2, y2 right here. So using the formula, it's y2 minus y1 over x2 minus x1. So we got 4 numbers to put in. Y2 is -16, y1 is 0. X2 is 0, and then x1 is 2. So this ends up being -16 over a -2, which is going to be +8. And like we saw earlier, if we were to do this minima with this maximum, the only thing that's going to happen is the sign is going to change. So I'll have both answers in the answer key if this happens on the test. Okay, so now we have to identify A, H, and K. I'll show you how to type this stuff into the graph also. So A, H, and K are located in the same 3 spots of every graph there is. The A is in front. So the A in this problem is going to be the -1 in the front. The H is on the inside, and the H is the one that people always miss because you're supposed to set the inside stuff equal to 0 and solve it. So that causes the sign to flip. So this is going to be a -4. And then the K is going to be the one at the end. So the K is just going to be 5. That's going to be your up and down movement. So I'm just going to show you real quick. It says to graph it, but I'm not going to graph it because on the test, we don't have the capability to make a graph. So we're going to head into the graph here to just look at it. Usually we could just kind of match up the picture. So let me move this out of the way. So we're going to have negative parentheses. Remember that when you put the X, it has to be the X button above the ABC button. That's the only button you should use. So X plus 4, parentheses. Squared is the X squared button, and then plus 5. So if you want to match it up by picture, you can go ahead and graph it using the graph, or you can go into the menu and head over to the table. So if I go to the table and hit execute twice, it gives me a list of numbers that I can match up with any graph that they show me. Now keep in mind that a lot of our graphs only go from -10 to 10. So that's -7, -4 is probably the first one that I would check if I was you. Okay, the next one, identify A, H, and K. A is in front. There's nothing in front, so that's a 1. H is on the inside, and it's always opposite, so that's going to be a -2. And then your K value is the number at the end, so that's going to be a -1. So again, I'm going to show you how to type in an X to the third. When you guys type in an X to the third, for this right here, you have to type in the caret key and then 3. So if I go over to my graph, I'm going to hit exit. I'll delete the function, and then I'm going to put parentheses X plus 2. Oops, I forgot the X. X plus 2. And then I hit the caret key. The caret key is located next to the X squared button. So that puts the 3 up there. Now you have to be real careful, because if I put a -1, this thing is set to stay up there. So you got to kind of move the cursor to the right, so that way it lowers it down to the regular level. So I put the -1 there. And if I want to see the picture, I go into the graph, and there's my picture. I can match that up to the multiple choice on the test, or I can head over to the table to find some specific numbers and match those up. Now again, you can see that these are huge numbers. So we're going to have to scroll down until we see some numbers that are in between -10 to 10. So that's probably going to be the first point that you would see on the graph paper. It's -4, -9. And then if you continue to scroll, all of these should land somewhere within the boundaries of our graph. Not so much these here, because that's off the charts right there. Our graph only goes up to +10. Okay, next one, A, H, and K. A is always in front, so that's going to be -2. H is always on the inside, and it's opposite, so that's going to be -1. And then K is going to be at the end. That's at -3. So then what we're going to do is talk about how to get these symbols here. So if I want to do a cube root is going to be the yellow shift button and then the open parentheses. So I'll show you how to type that in real quick. I'll hit exit to get back to the equation, F2 to delete, and F1 saying yes, I'm sure. So I'll stick in a -2, and then shift and open parentheses, and then X plus 1. Now when I put my -3 on the outside, I got to make sure that I get out from underneath the cube root. So I have to hit the cursor to the right. Another thing that I've noticed a lot of people do is they use the -3 like this. That's going to give you a syntax error, so you can't really use that one. So you're going to have to make sure that you use the minus sign and not the negative. So let me go back and put in a minus, and you can see the minus sign is a lot longer. And then there's my numbers from my table. If you have decimals, like, you can estimate the decimal, but really when I graph, I just use the integers. Integers are like positive and negative whole numbers. So I would skip over all these and then maybe just graph -2, -1, and -1, -3, 0, -5, and so forth. Okay, A, H, and K. Hopefully you're noticing this pattern, because, I mean, A, H, and K, if you learn these now, it works on every single graph there is. So A is in front, so A is -2. H is inside, and it's always opposite, so that's going to be -1, and then your K value is going to be at -3. Now, in order to put absolute value bars in a graph, there's 3 buttons you have to hit. There's the option button, then you have to hit F5, and then you have to hit F1. So I'll show you that. So I'm going to hit exit to go back. I want to go up to this graph. You can actually You can delete the graph by just like typing over it and it just deletes it. Or you can hit the delete button, or you can hit F2. So we're going to stick in a -2. And then we're going to hit Option, which is to the right of the yellow shift button, F5 and F1. And then X plus 1. And then we go to the outside of the absolute value and we stick our -3. So if I go over to my graph, I should expect to see a V shape pointing down. There it is. And then if I want the actual numbers for the points, I can go into my table and then scroll down until I get somewhere between -10 to 10 for all the numbers. Okay, next is describing the transformations. It's kind of similar to what we just talked about. If we're going to describe our transformations, we basically compare it to the parent function. So if you find your h and your k, this is kind of an easy way to figure out which way your graph is moving. So the h and the k is just going to be 0, 0 here because h is inside and there's nothing inside, and k is outside and there's nothing outside. So if I list my transformations, let me start with the front. I have a negative, so a negative is going to be a reflection. Then I have this 2. Anytime you have a number higher than 1, that's going to be a stretch. You can also call it, you can say stretch by a factor of 2, but as long as you say the word stretch, I'll give you the points. And then if we find where this thing ends, this thing is going to end at +1, +4, because that's your h and your k value. H is always opposite. So if you just compare your x values, so let's say this is my x value and this is my x value, this thing is going to start here at 0 and it's going to end at 1. So if you just think about like the number line, so this is 0, this is the x-axis. If I start here at 0 and I end at 1, that's where I ended, I just went 1 to the right. So this is going to be 1 right. And then if I do the same thing for the y's, so if I start at 0 and end at 4, here's 0 on the y-axis, so I go 1, 2, 3, 4. So obviously I went up 4. So you don't really have to draw these pictures because the starting point is at 0, 0. But it's gonna help us once we get away from 0, 0. So again, this right here is the start. So the start is at 0, 0. And this one right here is going to end at -1, -9. So let me talk about the front first because there's a negative here. So anytime you see a negative, that's a reflection. So if we look at the x's only and we start at 0 and go to -1, that's going to be left 1. And then if we look at the y-axis and we're starting at 0 and then we head down towards -9, that's going to be down 9. And again, it's obvious because like you don't even need this part right here since it's at 0. But this next question is going to be kind of necessary. So if you look at the front, there's nothing in front, so we don't have to worry about that. So we just have to look at where it starts and where it ends. So this thing starts at -1, 5, and this thing is going to end at 4, -1. So if you just take it piece by piece, let's take a look at the x's. So we'll graph the x's. So I'm at -1, and I have to go over to 4. So this would be 0, 1, 2, 3, 4. So if I count that up, and this is 0, that's going to be 5 to the right. Right, 5. And I knew that because from -1 to 0 is 1, and then from 0 to 4 is 4. So 1 plus 4 is 5. Then I look at the y-axis. The y-axis is going to start at 5, and it's going to head to -1. So 4, 3, 2, 1, 0, and then -1. So like I mentioned before, this right here is 1, and then from here to here is 5, so that's going to be 6. And since we're starting from 5 and going towards -1, that's going to be down 6. Okay, this one has something in front, so we're going to have to mention that. Anytime you have a fraction in the front, something between 0 and 1, that's going to be a compression. A compression makes your graph shorter and wider. And now we can do our starting and ending points. So we're going to start at 3, -2, and we're going to end at 7, comma 10. So I just take it piece by piece. I'm going to look at the x-axis. So I'm going to start at 3, and I need to end at 7. So 4, 5, 6, 7. That's going to go to the right. So if I go from 3 to 7, that's 4. And then the y-axis, I'm going to start at -2, and I need to go up to 10. So there's 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10. So from 0 to -2, that's 2. And then from 0 to 10, that's 10. So that's going to make 12. So we're starting at -2 and heading up towards 10. So that's going to be up 12. And then this next one, we have something out in front. So we have a negative. So that's your reflection. Then you have the 3. Anything higher than 1 is going to be a stretch. And then we can go ahead and start looking at the starting and ending spots of these graphs. So this first one is going to start at 2, comma 7, and it's going to end up at 0, comma -1. So there's no number in here, so you just use 0. A lot of people want to use 1 because they think x is 1, but no, we have to use 0 because it's the number in the second spot, and there is no number there. So on the x-axis, we're going to start at 2, and we need to go to 0. So we go this way. That's going to be left 2. And then we go on the y-axis. So we want to start at 7, and we want to go to -1. So 6, 5, 4, 3, 2, 1, 0, -1. So that looks like it's going to head down 8. There's our answers. Okay, next we can kind of work backwards. So this says write the square root function. A square root function uses this symbol here. So I'm going to do f of x equals, I'll do a square root over here with an x on the inside. So there's 3 spots we got to fill. First, it says it's reflected, so that tells me it's a negative. Then it says left 3, but remember that when it's left and right, it's opposite. Left 3 would have been a -3, so I'll stick a +3 in here. And then it says up 2, so I'll put a +2 on the outside, and that's my answer. Next one is a cube root. A cube root is one of those guys. So same thing as before, so I'll do f of x is equal to a cube root. I'll leave some space in case I have to put stuff in front. It says stretched. Stretched is in front, so that's a factor of 2. Right 1. Right 1 means, right 1 is +1, so I'll stick a -1 in here, and then we're going to have the x right there. And then we're going to have up 6. So up 6 is +6 on the outside. Quadratic. A quadratic function is something to the second power. So we're going to start off with y equals, we'll go ahead and put an x like this, squared. And let's see what it says. Compressed by a factor of 1/3, compressions go in front. And then reflected over the x-axis means that we'll have a negative in front. So we didn't even need that huge parentheses. Now this is the answer, but if you want to simplify this, you can write y equals -1/3 x squared. So either one of these answers is acceptable. A cubic function is something to the third power. So we'll go y equals, I'll put a cube up here and an x right here. So we've got reflection, so that's a negative in front. And then left 5, remember left and right is opposite. So if I go left 5, that's a -5, so I'll have to put a +5 here. Okay, next one is the absolute value. When we say absolute value, those are the 2 bars. So we're going to say y equals with the 2 bars here and the x on the inside. So we've got the reflection, so that's negative. It says down 5, so be careful with this because they don't always give you your stuff in order. So down 5 would be on the outside over here. And then we have our right 3, and that's our special one. So right 3 would be a +3, so that means I stick a -3 in here. That's my answer. So describe what A, H, and K do. So if A is a negative, that's going to be a reflection. If A is bigger than 1, that's going to be a stretch. And then if A is between 0 and 1, so basically a fraction, that's going to be a compression. So that's just a summary of what A does. H is going to be easy to remember because that's horizontal. So horizontal shift means left or right. Oops. Remember that one's special. It's always opposite. And then K is your vertical shift. An odd example, and here's the reason why. I have a section of graph that's in the top right corner, and I have a section of graph that's in the bottom left corner. So a lot of times when you end up with graph in opposite corners, diagonal from each other, a lot of times that's going to be odd. There's a way that you can tell for sure, and I'll show you that right now. So if I take this graph and basically make a copy of it, so if you notice, like I can take the picture and spin it, so that would land directly on top of it. So even if I spun it around this way, if I turned it 180 degrees, it lands directly on top of itself. So that's another way you can tell that these graphs are going to be odd. And then your example for neither is just none of the above. So you can't fold it in half, and you can't do a double fold or spin it upside down and get the same exact picture. And that's your entire test review. So hopefully you guys watch this, and hopefully it helps you on the next test.